Okay, let's review real quick. This problem with the two schools. So let's just say this is school number 1 and this is school number 2. Now they said that 70% of the kids did their homework at school number 1 and 50% did their homework at school number 2. Remember? Okay, so this is how we find the standard deviation. Just remember, so the proportion, 1 minus the proportion of school 1, and then the sample size. So in the first school, they took a sample of 100 students. So N1 would equal 100. And in the second school, they took a sample size of 200. So N2 would be 200. So that's where all this stuff comes from. So 70, and this would be 30 divided by 100. This would be 50 and 50. See, 1 minus 50. And this would be 200 because of the sample size. And take the square root of this whole mess. That gives you the new standard deviation. That's kind of the new thing for this chapter. Okay, so in this situation, they say that the two counselors, they poll 100 students, and they actually get p hat of school number 1 and p hat. Now, they don't tell you what they get, right? But all they say is when they subtracted those two proportions, they got 0.10, which is interesting because you would expect 70 minus 50, you should expect 0.20 between these two schools. So what is the probability that we would get a difference of this small or less? Let's do that. Now before I go to the next screen, what I'm going to do is, so here I plugged all those numbers in for this big fat new formula, and I come up with an answer of 0.058, 0.058. So that's our new standard deviation for the situation. Okay, now what's next? So we go back to our old friend, the Z-score, right? So it's going to be a Z-score, and what do? Well, the value that we got minus the value that we expected to get divided by the standard deviation, which is 0.058. Yeah, we've done this before, and we're going to get a p-value. Let's see what this is. So this value that I get for this Z test, I guess you would say, is equal to negative 1.724. So it's kind of like this. Here's our graph, right? Here we are at 0, negative 1.724 standard deviation. So it's down here, negative 1.724. And again, we're looking for this area, and that would tell us the probability that if it was true that 70% and 50% in those two schools did their homework, what's the probability that we would get a value of 10 or less? So I throw that into normal CDF, and I'm not going to subtract it from 1 because we're on this lower side, and we get a p-value of, what is it, 0.042. What does that tell us? Well, if it's true, the homework rate of those two schools, getting a difference of this much or less would happen only 4% of the time. So you can imagine if we were doing a significance test at alpha level of 0.05, you would reject this and say, you know what, I think the kids, it's different. Those values are not, it doesn't really give us a lot of information, but all we know is that we can just tell the principal that we think that the 70% and 50% are probably wrong. Okay. Stop there for a second. So the next thing we're going to work with is, well, why don't we do a confidence interval for this situation? So here's the formula. And this should look similar to what we did, when was it, in chapter 9, I guess? So basically, here's the thing that we got, right, when we subtracted the two values. This is our Z-score, and then we got that new crazy, that big new standard deviation. So in this school problem, what do we have? Well, when they subtracted the two proportions, even though they didn't tell us what they were, we got 0.10 plus or minus. So let's do this. Let's just say it's a 95% confidence interval. Now, do you remember what that is? I think it's 1.96. I'm going to double check. 1.96. And then what was that standard deviation from the problem? 0.058. 0.058. There it is. So what I do is I multiply these two numbers and add it to 0.10, and I multiply these two numbers and subtract it from 0.10, and I get this as my interval is 0.0136, 0.2136. We were 95% confident that the true difference between these two schools is somewhere between these two numbers. Now this is interesting to me because 0.20 is inside this interval, even though we said we might reject the null hypothesis. But notice it's kind of on the high end, and the low end is pretty close to 0, right? So I would think that the schools would be more closely related. Instead of like 70 and 50, those numbers are closer together. But anyway, that's just me thinking about stuff. So there's that. And we're going to work with this next, this whole idea of the confidence interval.